Welcome to Scaling Up H2O, the podcast where we celebrate Industrial Water Week. Happy Industrial Water Week, everybody. Today is Cooling Wednesday, and if you've just joined us, we are celebrating each and every day this week of Industrial Water Week, the fifth time we have celebrated Industrial Water Week. Industrial Water Week is always the first full week of the month of October. And we start out the week celebrating Monday with pre-treatment. Tuesday is boilers. Today, which is Wednesday, we celebrate cooling. Tomorrow, Thursday, wastewater. And then we wrap up the celebration with career. So an entire week of celebrating us, the industrial water treater, the best profession in the world. And today, Wednesday, is all about cooling. You know, we have some amazing cooling tower manufacturers out there. And so many of those manufacturers are joining forces with water treaters and the industrial water treatment nation, community, to make sure that we're sharing and gaining good information. Now, some of these manufacturers are really good friends of mine. And of course, I'm talking about the fine folks at Avapco. And if you want to enhance your knowledge about cooling towers, by the way, a great way to help you celebrate Industrial Water Week's Cooling Wednesday, well, here's something that you can do. You can listen to episodes 137 and 138, and you will hear, if you listen to those episodes, Avapco's Brett Alexander joining us to talk about all things cooling towers. In fact, he does a fantastic job of bridging the gap of the terminology we use in the industrial water treatment industry and the terminology that the manufacturers use. So even if you've heard these episodes before, I urge you to go back and listen to episode 137 and 138. I guarantee that you will learn something new. And after all, it is a great way to help you celebrate Cooling Wednesday. Here's something else to help you celebrate Cooling Wednesday. Here's James McDonald.
Hello, Scaling Up Nation. Happy Industrial Water Week. As we celebrate Cooling Wednesday, I am reminded of a client that had a large 3-cell cooling tower system that was having problems maintaining conductivity. The cooling tower had 2 possible makeup water sources. The primary makeup source was tertiary RO water from wastewater treatment at 175 microsiemens. The second makeup water source was well water at 480 microsiemens. The operator noticed that when the tower was running on well water, they were able to maintain the proper conductivity of the cooling tower. But when the tower was running on tertiary RO water, they were not able to maintain the proper conductivity. What was happening? Was it a faulty controller? The conductivity controller was able to properly maintain conductivity on well water. The connectivity controller was not the problem. Was the blowdown valve leaking? There was an air gap between the blowdown line and the drain. The blowdown valve was not leaking. Was it an uncontrolled water loss? The answer was that there was an uncontrolled water loss somewhere. This water loss was bigger than the blowdown required when the cooling tower was on tertiary RO water makeup, but smaller than the blowdown required on well water. So was it drift, overflow, or another type of leak? We inspected the cooling tower and saw no drift nor overflow from the tower that would explain this sudden change in operation. There must have been a leak somewhere, but how big of a leak? Using the cooling tower operational parameters, I calculated just how big the leak was. Operating on well water, the blowdown would have been around 40 gallons per minute. On tertiary RO water, around 12 gallons per minute. I calculated the size of the suspected leak to be at 33 gallons per minute, which was between the 2 blowdown numbers just mentioned, as I predicted. This clearly shows why the cooling tower could maintain the connectivity setpoint on well water, but not on tertiary RO water. Since the blowdown valve was completely closed when they were currently running on tertiary RO water, this meant there was a 33-gallon per minute leak somewhere, a sizable leak indeed. The cooling tower system was used to cool several rather complicated processes with many heat exchangers, so finding the leak was not going to be easy. To complicate matters more, due to the proprietary nature of some of the processes, the operators and I weren't allowed in some of the areas to search for the leak. Everyone we contacted denied the leak was in their area. We came up with the idea of adding a red dye to the cooling tower to make the leak easier to find. Mysteriously, after adding the red dye and communicating this to the surrounding buildings, the leak suddenly disappeared and never happened again. I like this story because it made me think about the mass balance around a cooling tower, plus I got to use my mathematical skills to conclusively prove my suspicions. I also like this story because despite the assurance that the leak wasn't in any of the areas we called, it mysteriously disappeared when the red dye made it undeniable. I hope you enjoyed today's story on water, and equally hope you will share one of your own on social media to help celebrate Cooling Wednesday of Industrial Water Week. Don't forget to tag them with hashtag IWW22 and hashtag ScalingUpH2O.
If you're a member of the Scaling Up Nation, if you listen to this podcast, you know that I love math. It's one of the subjects that I get the honor of teaching for the Association of Water Technologies. It's one of the things that I think I can help so many people embrace with feeling confident about using math to help solve our water treatment mysteries. And I love James's story because it is a great example of how you can use math. Didn't really solve the issue, but it allowed him to start looking for the issue. It also reminds me of a very similar story. My father and I, when I first started in this industry, we had the Albemarle County Municipal Buildings. That's in Virginia. And we were in one of the public buildings, and we kept losing closed loop treatment. It was in the hot loop. And we looked all around. We could not find a leak. And of course, they did not have a water meter on it. Every time we went there, there was no treatment in the hot loop. So we finally met with the gentleman that was over all of those buildings, and we just walked around the building. It was about a 2-hour tour, and we went into every single room. And I should have played the lottery that night because you do not get any more lucky than what I am getting ready to tell you. We went out to the loading dock, and the janitor was washing his van with hot loop water. And of course, all this steam was coming out of the hose, and we found our leak. And we said, "What are you doing?" He goes, "Well, I'm washing my van like I always do." And we said, "Why are you using hot loop water?" And he goes, "You idiots, it's cold out here." Now, of course, I added the embellishment of "you idiots," but it was implied. Well, we educated him that that was not a proper use of the hot loop water. And we explained to him that that was for heating the building. And he was just going to have to use the hose bib that was actually a lot easier and closer for him to connect. But let's face it, we put hose taps on hot and chilled loops all the time, and people will use them. I have another story where a landscape crew, actually it was in the same facility now that I think of it, a landscape crew was using chilled water to fill up their water coolers for the day because it was pretty cool. They didn't have to melt their ice. They could just put this water in there. Well, they probably realized that when they first did that in the beginning of the month, it tasted really weird and probably gave them some side effects that I won't go into on this family show. However, we're able to find that as well. And we did the same thing that James did. We started putting dye in the loops. We had a red dye in the hot. We had a blue dye in the cold. And I know a lot of listeners out there use phenolphthalein as a pH indicator, and that has a pink dye residual to it. So you're able to note that, hey, this is not the right type of water. So I'm curious, are you using dyes in your closed loop systems? If you are, do you have a story about it? Do you have another story that you want to share with the Scaling Up Nation, with everybody who is celebrating Industrial Water Week? Well, I sure hope you do, and I hope you share that just like I shared my story with you. But for you, I would love for you to share it on social media, just like James suggested. And when you do that, hashtag it with IWW22 and Scaling Up H2O. Well, one of the other ways that we are helping you celebrate this amazing holiday is we're doing mini interviews each and every day on the theme of the day, and we're making them shareable and very easy for other people to understand the basics of the themes of the day. So today we're talking about cooling, and I hope that you use these little interviews to share with people that you want to help educate about the topic. Now, you get to choose who you share them with, but I sure hope you choose, because when people understand what it is that we do better, our industry gets better. Your job gets better because people understand why it's so important for them to take our recommendations. So whoever you share this interview with, I just hope you share it. And here is today's interview. My lab partners on this Cooling Wednesday are two Ketricks, not just one, but two. We have Bruce Ketrick Sr. and Bruce Ketrick Jr. Bruce's, welcome to the Scaling Up H2O podcast.
Thank you. Happy to be here.
Well, I thought what we would do today is talk a little bit about cooling to celebrate Cooling Wednesday. And I guess before we do that, how are you guys celebrating Industrial Water Week? What are you guys doing?
Yeah, we actually do a daily Instagram, Facebook campaign around Water Week, and we pretty much steal most of it from you. So in other words, feel complimented, because the height of a compliment is to plagiarize someone else. So it's all about you, Trace.
Well, and Bruce Sr., I am pretty sure I have done that from your material. So there we go. We're just sharing the wealth. How would you all describe cooling to somebody that is just starting out in this industry?
For me, it's pretty simple. I just talk about the fact that when you get to large industrial size cooling, and you're going to move a lot of heat from a building, it requires the use of water. And our industry, we really just keep those assets alive so they don't rust. Like if you left a hammer out overnight, it would turn into a rusty hammer. And these are pieces of metal that have water running through them all the time. And then we also are tasked with making sure that we do that in an efficient manner so that we're saving energy and making them run as efficient as possible. So with that takes some chemistry, and it takes some monitoring, it takes some testing. But at the end of the day, all we're doing is just taking heat out of a building and then using evaporation to cool that building or that process down.
Bruce Sr., you want to add anything to that?
Yeah, I mean, I look at cooling as the opportunity to improve people's lives. And the more efficiently we do that, the less energy is utilized, the less water is utilized. And conservation of those are important aspects in what we do in our everyday life.
Bruce Sr., let me ask you, how have you seen resources been better guarded or better protected as the industry has advanced?
When I first started doing this, cooling water was pretty much add chrome, drop the pH down to 7.5. Don't worry about biocides, because the chromate was toxic enough to kill all bacteria. And don't worry about the fact that we're now poisoning our environment to an irreparable point. Today, we're looking at greener technologies, using plant derivatives to make raw materials so that we have non-toxic products that are both corrosion and scale inhibitors that reduce metal loss, that control bacteria and can be discharged back into rivers and streams safely. It's been a massive change over the years.
What would you say some of the primary concerns are around cooling?
So because the cooling systems that we deal with are typically water-based cooling systems using evaporation, the four primary concerns that I see are we've got corrosion, right? So we got to make sure that that metal loss, the water on that metal doesn't rust or corrode the system. You've got biological concerns. So in that case, we worry about fouling, and we also worry about, an industrial hygiene, which is, is that going to get somebody near the area sick? And Legionella is one we think about because it is aerosolized. There's asset management. So we want to make sure that the piece of equipment that we're actually trying to keep clean and run efficiently lasts for a really long time. And then there's energy management. And I think more recently, that energy management piece has gotten way farther into the forefront. And even with today's environment in the last 6 months, it's becoming, even a bigger push to really get into that. So the scaling piece, the biological control piece, corrosion scaling, biological control, and then that asset piece with efficiency, those are critical for us.
Bruce, do you want to add anything to that?
Yeah, I agree with what was just said. Those are the primary areas of concern. And as we advance in our technology, we're able to do that better and better. I mean, it's amazing how 30 years ago, 40 years ago, the major concern was scale and corrosion. If we don't have scale, we don't have corrosion, we're fine. We didn't understand biological. We didn't understand a lot of the fouling. We didn't understand a lot of the reactions between biological and metallurgy, and just accepted them. And today it's become extremely evident that water is such a valuable resource that it's being watched just at every step of the way. And biological has become a huge part of that, especially the hygiene sector, which I think is going to expand dramatically in the future.
What do you feel everybody should know if they're an industrial water treater and they're working in cooling?
There's a number of things they need to know. They need to understand what they're dealing with as far as the equipment. They have to understand safety concerns in particular. What are the potentials of exposure to the water that they're dealing with? How do they make that water as clean as possible? What is the potential contamination factors from those systems in the locale that they're sitting in? I mean, there's just a tremendous amount of things they need to understand with cooling water. It can be simply explained, as Bruce said earlier, with I'm extracting heat from a building, which is really what it is, and as intricate as understanding every bacterium that's in the water and how to handle it properly.
I would add understanding what corrosion looks like, so you know what metal loss looks like and what that can do. I would also say you really, really need to have a good, solid understanding of what earth metals are floating around, calcium being the biggest one in the water, and the fact that that's inversely soluble, and the fact with heat especially, and that's going to cause insulation and reduce efficiency, and what that looks like and how that happens. Understanding how far you can stress water with concentrating it. We evaporate pure water and leave all the dirt behind, and some of that dirt can really make a problem. So you need to know when you got to get rid of it and add some fresh water. And if you don't understand that, that's the real basics, are just getting to that point of how far can you push, how much water you can save, because the goal is to save as much water as possible without causing the fouling or causing the scaling or causing the corrosion. If not, we just run a once through system and let water, heat transfer right there, and we wouldn't have to worry about any of this stuff.
What would you say your funniest cooling story is?
Well, my funniest cooling story, I know I can instantly know exactly what that is. We had they're evaporative condenser systems, which typically have water just inside the cell. But this was a big 4-cell system and a big straight pipe that came down to a huge circular tank inside. And when we took the account over, it was heavily scaled, meaning there's a lot of calcium deposits on all of the heat transfer tubes. And I got the cleaning procedure backwards. So what I did was add the cleaner that was going to remove and bring all that calcium into solution, which also makes a lot of foam and did not add a sufficient amount, nor did I have even on site with me a sufficient amount of the foamer. So as that was coming down from about 30 feet above me into this big, huge pit, really violently, it made the entire room filled to like my ankle level of foam, the entire mechanical room. I ran out to a pool supply store and got the foamer because it was the closest thing I could think to do, and came back and they, went and grabbed the maintenance guy, let him know what was going on. The guy who ran the facility came down, and after I spent a good 10 hours cleaning that room up, and it was brilliantly clean now because everything had been wet, he laughed at me and thanked me for cleaning his mechanical room. But that is one I will never forget.
That's great. Bruce Sr., how about you?
I was running a trial at a refinery that no longer exists. And after we set everything up, and of course, that's before we were able to dial into things like we do now, came around the next week, and we were told that the tower wasn't functioning as efficiently as they had been. And obviously, our product was failing. So we went out to look at the tower. There was this 10-foot bladder laying on the ground, which turned out to be one of the fan blades. When the fan blade shot out of the plenum, they ripped the plenum apart, so all they were doing was just free cooling. So you find out that your maintenance guys aren't as up to date as you thought they were when you run out to the tower and find that it's been apart for over a week.
Well, and the old adage, proven true again, when in doubt, blame the water treater.
Yes, it was our fault that the fan blade came apart and tore the plenum apart.
Yeah. How does your product even help protect for that?
We're not sure, but obviously you should have been.
Well, guys, thank you for spending Cooling Wednesday with us, and happy Industrial Water Week.
Thank you.
Thank you.
Nation, there's no doubt about it. If you're in the water treatment industry, you have met a water treater that loves telling stories. And most likely, you are one of those water treaters. Some of the best stories that I found come when I ask the question, what do you wish you knew when you first started in the industry?
Hi, this is Russ Baskin, President and Visionary of Tower Water. And what I wish I knew when I started in water treatment was everything there is to know about algae and cooling towers. Many times in the beginning of my career, I came across this particular concern. I remember my first time going up to a cooling tower. I knew what algae looked like. I had swimming pools when I was younger, but I came up to this cooling tower, opened the door, and the tower was completely green. The water was crystal clear. I was all proud of the water treatment. All my readings were great. My bacteria was nice. But when I inspected the cooling tower, it was green. Everything was green, from the basin of the tower to the fill to the fan blades of the tower, completely like it was painted that way. And, this was something that was mentioned in my training, but nobody ever really took me up there and showed me what something would look like. And of course, you're sitting there with the client, and the client has to tell you what a terrible job you're doing. It's the water treater's fault. And you probably have Legionella in my cooling tower. And, what I realized was that, these issues with algae, it's allowed to be in some places, not allowed to be in others. We had, chemicals that were called algicides that don't always work so well. And it's a completely different problem than just testing your water, adding treatment to it, and going on with your business. All right. Once it gets to a point like that, it's got to be mechanically clean. So we're talking about pressure washing and hose washing down a tower, costing money, aggravation, time, and then you got to make sure it never comes back. So that's what I wish I knew my first step out into the water treatment world. Had I known that, it would have saved me a lot of aggravation.
Nation, if Russell Baskin's voice sounds familiar, that's because you heard him during Legionella Week. That was episode 265. And we had so much fun. We brought him back the next week for episode 266. So if you want to hear more from Russ, by all means, listen to those two episodes. Russ had his entire company turned around when New York enacted their Legionella laws. So there is so much that we can learn from Russ, and he shares all of that on those two episodes. Now, speaking of Russ's story, something that I immediately thought of as he was speaking was a counterflow induced draft cooling tower. If he would have had one of those, that would have mechanically eliminated all of that algae. How does it do that? It eliminates sunlight from getting into the tower. When it comes to algae, if we don't have sunlight, we do not have algae. And how many people do you know have changed their cooling towers out and they never gave consideration to the design? Well, folks, if we can eliminate the light coming into the cooling tower where it sees water, we don't have to deal with it. And it's so much better if we do not have to deal with algae. Now, if that's something that sounds interesting to you, or if you've never heard the term counterflow induced draft, by all means, do what I suggested in the beginning of this episode and listen again to episodes 137 and 138, where all of that terminology is explained. And again, a great way to help you continue your celebration of Cooling Wednesday. And I'll say one more time, my favorite, absolute, positive, favorite way to celebrate Industrial Water Week is to read all of your stories, to look at all of your pictures that you're sharing on social media and hashtagging them with IWW22 and scaling up H2O. A great way to celebrate, and you're going to make me so very happy. Today is Cooling Wednesday, and cooling is the only reason that I can live here in the South. I would not live in Atlanta if I could not cool and take the humidity out of the air here. I'm sure you have heard Atlanta referred to as Hot-Lanta. Boy, are they not kidding. Did you know that air conditioning was invented by Willis Carrier in 1902? He got inspiration while walking on a foggy train platform, and as he walked from the train, he realized that he could dry the air by passing it through water to create a fog. Doing so would make it possible for him to condition the air with a specific amount of moisture in it. After that realization, within a year, he completed his invention to control humidity, thus creating the foundation of modern air conditioning. I love invention stories. They're just fantastic. If you're a fan of the History Channel, they're all over there. They're all over the internet too. That's one of my favorites because that allows me to have a livelihood. Thank you, Willis Carrier. I have a job because of you, and I absolutely love that job. By the way, another fun fact, in 1889, Charles Duell, who was the commissioner of the U.S. Patent Office at the time, stated that the U.S. Patent Office will soon close down. And here's his quote. The reason the U.S. Patent Office would soon close down, he says, everything that can be invented has already been invented. Well, it's a good thing they hung in there to accept the patent for air conditioning. That's all I have to say. Happy Cooling Wednesday, everybody. Here's another encore episode of Detective H2O, and today you're going to be enjoying the case of misdiagnosis.
Welcome to Detective H2O, the case of misdiagnosis. The birds chirped cheerily as the sun shone brightly through the streaked office windows of Herbert Henry Oxidane, P.I., CWT. Detective H2O squinted out the window uncomfortably. I don't like it. Everything is so bright, it's hard to see what's going on out there. I'll take a good drizzle any day of the week. The first clap of thunder and the black mid-20th century phone both announced themselves at the same time. On the third ring, the water detective answered the phone. Detective H2O here, the best water treater this side of the Ohio, solving water problems drop by drop. What you got?
Mr. Oxidane, this is Misty from Widgets BS. You might not remember me, but we met a year ago when you inspected our water tube boilers.
Detective H2O remembered Misty all right. He couldn't forget the sweet smell of lemon verbena perfume. He had worked shoulder to shoulder with her as they climbed through 3 water tube boilers during the summer plant shutdown. Yes, I remember you. Inspection, water tube boilers. You passed. Your boilers passed with flying colors.
Yes, that was us. We need you again, but this time for our cooling towers. We're having problems with our microbiological control feed program. Something is not up to snuff about it, but we don't know what. Can you fit us into your busy schedule, Mr. Oxidane?
Let me check my calendar, said Detective H2O as he ran his finger down the empty page. Yes, I happen to have an opening this morning. I'll be there within the hour. Will that work?
Of course, Mr. Oxidane. I look forward to seeing you in an hour.
Detective H2O cracked a crooked smile as the rain started during his drive to Widgets BS in his old Ford. He was looking forward to this visit. Making his way beyond the guard shack, he headed straight to the powerhouse. Misty Downs was just inside the door, silhouetted by a burst of steam from a recent boiler blowdown to the drain. Arms on her hips as she walked towards him, she exclaimed,
Mr. Oxidane, I'm so happy you're here. Follow me.
Putting up no resistance, the water detective gladly obeyed. When they reached the water testing station, Misty said,
Look at this, Mr. Oxidane. The free chlorine levels have taken a dive, right out of the blue. All of a sudden for the last 3 shifts. We don't know what's going on. We've turned up the bleach pumps, but no luck. Now, I'm smart enough to know there are 2 sides to the oxidation coin. One side is demand. The other side is residual. You can't have a free chlorine residual until you've met demand. We've been racking our brains, see? Is there process contamination? Perhaps oil leaking into the system, causing an increased demand. I guess on the flip side, are those little microbiological critters multiplying at such a rate that we just can't keep up with demand? We just don't know, Mr. Oxidane. We just don't know.
The water detective scratched his chin as he thought. Let's take this one step at a time, Misty. What you say is correct, but let's start from the beginning. Can you give me a sample of the cooling tower water? We need to run some tests.
Sure,
replied Misty. A moment later, she was back with sample in hand. Detective H2O started his barrage of testing, beginning with the free chlorine test. It was completely colorless, but his sharp, well-trained eye did catch something immediately. He moved on to the rest of the testing, including total hardness, total alkalinity, conductivity, pH, and tracer. This is interesting. Can you take me to the sodium hypochlorite feed station and cooling tower basin, please?
Of course. Have you found something, Mr. Oxidane?
Maybe. When they arrived at the sodium hypochlorite feed station, the water detective noted the pulsing of the dosage pump in his tubing. With a flooded section, priming did not appear to be an issue at this point. The pump was pumping to beat the band. Moving on to the cooling tower, he noted a fine white foam covering parts of the sump's water surface. Some of it got caught up and flew out the top fan as he took a peek inside the cooling tower plenum area. Detective H2O then led Misty back to the sodium hypochlorite feed pump, which he swiftly turned off. With her mouth open, Misty asked,
Why did you do that? We don't even have a free chlorine residual, and you're turning it off? Don't we need more bleach instead of less?
The water detective took a moment to enjoy the perplexed look on Misty's face before revealing his hand, A full house. A little crease formed between her eyes when she was perplexed. You do have a good understanding of the basics of oxidizing biocides, Misty, but I believe you were blinded by the light on this one. Let me show you. The water detective led her back to the water testing station, poured the cooling tower water sample into a sample vial, and said, "Now watch what happens when I place the free chlorine test reagent powder into the sample."
It's just clear, Mr. Oxidane. That means no free chlorine.
"No, watch again," said Detective H2O as he rinsed and reported the sample. "Come closer. Watch the very beginning, right when the reagent first touches the water sample." As Misty and Detective H2O stood cheek to cheek watching the free chlorine test reagent powder pillow drop into the water sample, it happened. Did you see that, Misty?
Yes, I did. What does it mean?
That flash of pink you saw as the free chlorine test reagent powder hits the water proves there actually is a free chlorine residual in your cooling tower.
What? Why? How?
Did you notice the other test I ran before? Did you notice the colors some of them changed? The total alkalinity test, for instance.
Yes. I did notice that one test in particular turned different colors than normal. Instead of a green and reddish transition, the colors were blue and yellow. I just figured you were using a test I hadn't seen before.
No, Misty. It's the same total alkalinity reagents most every other water treater uses. Did you notice the white foam on top of the cooling tower when we tuck our luck inside the plenum area?
Yes. I thought it was from whatever the contamination is. What's going on here, Mr. Oxidane?
Regretfully bringing his consulting services to a near close, Detective H2O finally revealed his complete hand. It's quite simple, actually. You're overfeeding your sodium hypochlorite. When this happens, it can bleach out the water analysis tests, giving suspect or erroneous results. The free chlorine levels are so high that they are bleaching out the free chlorine test almost immediately. But when you watch closely as the test reagent powder hits the water, you can see a flash of pink. That's the reagent doing its job just before it fades from the high sodium hypochlorite levels. Also, the total alkalinity test turned blue and yellow because the sodium hypochlorite overfeed. The tracer test was affected as well, so I suspect you may be overfeeding your inhibitor product too. Lastly, that white foam we saw in the cooling tower water was, once again, from the sodium hypochlorite overfeed. That's why I turned off the oxidizing biocide pump. Seeing her disbelieving look, the water detective tucked the cooling tower water sample, prepared a dilution, and ran the free chlorine test again. A beautiful pink color bloomed in the sample. See, once we properly dilute the sample, the free chlorine residual is clear as day. Smiling broadly, Misty gave the water detective a big hug.
Thank you, Mr. Oxidane. Or should I say Detective H2O. You saved the day.
For once, the water detective was speechless as his face turned the rosy pink of a free chlorine test. In the underbelly and penthouses of the metropolis of Waterville, where the boilers percolate and cooling towers fog, there is one man who works tirelessly to end corrosion, stop scale, fight low-life microbes, and conserve water. That man is Detective H2O, best water treater this side of the Ohio, solving water problems drop by drop.